Thank you so much. So this was a very simple video that we were also sharing on all our timelines. So firstly, a very warm welcome to everyone. My name is Vijeta Shastri. I'm the Executive Director of TIE Bangalore. And yes, some important and essential conversations today. It's about startups, it's about innovation, it's about climate change. But first, it gives me an honor to quickly talk about TIE Bangalore, and I would also like to give a shout out to Mr. T.R. Anand, who's part of the TIE Bangalore community and board member, and as well as a co-chair of the IoT Forum. So at TIE Bangalore, we focus on very simple things. How can we foster entrepreneurship? How can we support the ecosystem of startups, founders, and innovators? How can we help them to grow, get their funding, get their mentoring, and of course create these kind of wonderful programs where they can interact with thought leaders, they can interact with the finest people across the innovation cluster of academia, of investors, of thought leaders. And the IoT Forum has been formed to focus on improving and increasing the IoT quotient in India. Of course, it has been a very global play for us, and we have had many people from all across the world taking part. Again, the focus is what can we do for the entrepreneurs, the innovators, how can we bring people together and make the startup ecosystem super duper vibrant. With that, I would also now like to invite Abhishek. He's from Caspian, and he's going to be setting the context of what is going to be expectations that we will have today. And yes, a warm thank you and welcome to every single one of the other panel members and the audience who have joined us in. All right, so Abhishek, over to you, sir. And I'm going off video and audio because we are all students, and I'm here to also learn about what's going on. So thank you, Abhishek. Over to you, sir. Cheers.
Thank you, Vijeta. Thank you, everybody, for joining us on this session here today. A very warm welcome. So just to give you a little bit of a background, once again, like Vijeta mentioned, I am from Caspian Debt. And Caspian Debt is one of the largest providers of custom debt financing to startups and social enterprises in India. We've funded a little more than 160 companies till date. And the interesting thing is that about 50 of them, 50 of the startups and social enterprises that we have funded, which includes companies in the food and agribusiness and ag tech space, have direct impact or are, in fact, directly impacted by climate change. So the issue of climate change is not something that we just read about. It is also something that affects our portfolio companies. And while we regularly do this, we realize that it is not, just sufficient to consider the risks of climate in our portfolio and just leave it at that. We realized that it was more important for us to probably share the lessons that we learn from our own portfolio companies and some of the climate experts that we talk to from now and then. Uh, and also develop more innovative financing mechanisms to help our portfolio companies deal with the issue of climate change better. In fact, in a few weeks, Caspian Debt will be launching a new climate smart platform that does that, which is sharing of knowledge as well as implementing new financing products to help companies deal with climate change better. But before that, what we are doing today is we're trying to bring together, we've tried to bring together some of India's top climate scientists and the CEO of India's largest private weather data services company. And together they'll talk about things like what changes and patterns of weather are they observing, and what should an agribusiness or an ag tech company be doing to adapt to climate change. They'll also talk about aspects like what does it mean for the ability of ag tech companies or agribusiness companies to raise capital, or how do they grow their business and so on. So for the session today, we have Dr. Chirag Dhara from Kriya University, who's actually a contributing author to the book on assessment of climate change over the Indian region. Welcome, Dr. Dhara. We also have Dr. Shamashri Dasgupta from IIT Mandi. She is also a contributing author to the report on climate vulnerability assessment for adaptation planning in India using a common framework. We welcome Dr. Dasgupta. We also have Dr. Ramarao from the Central Research Institute for Dryland Agriculture. He is a contributing author to Risk and Vulnerability Assessment of Indian Agriculture to Climate Change. And also Mr. Yogesh Patil, CEO of SkyMet Weather Services, India's largest private weather services company. Welcome, Dr. Ramarao and Mr. Yogesh Patil. This session will actually be moderated by my colleague, Sanjay Sanyal, who leads Caspian Debt's initiatives in the environment and the climate sustainability space. He is a clean technology innovation and climate finance expert. So he's the best person to have this conversation with some of the top climate scientists that we've been able to bring in. And of course, Mr. Yogesh Patil, who, like I said, runs the largest private weather services company in India. So over to you, Sanjay, and I'll be a listener going forward. And I hope this is going to be a very interesting conversation. The request to the guests or the audience in the call is to leave their questions, if any, on the chat box. We will pick up a few questions as we go through the session. Over to you, Sanjay.
Thank you, Abhishek. I will have a few questions for you as well. Thank you, everybody, for joining in this afternoon. I already see people from all over the world, actually. Welcome, and we hope that we will make the next 90 minutes very interesting for you and worth your time. The way we will do this is that we will try and make it as interactive as possible. So as Abhishek said, please start putting in your questions in the chat box. But in order to frame our discussion, we do have a few sort of discussion points ready. So we will use that for the first 40 minutes or so that we have the rest of the other 40 minutes open to answer your questions only. I would start by asking my panel, that is, what is the time, what prompted them to enter environmental research? And I'll start with you, Chirag.
Thanks, Sanjay, and thanks to all of the Caspian team for inviting us today. So it's a real pleasure to be here. As for me, I was working in theoretical physics. So I was doing a PhD in quantum mechanics, quantum information theory, and this was 2008 or so when I began. Towards the end, when I was getting towards the end of my PhD, I started to think that I didn't necessarily see myself doing the same things 5-10 years into the future. So one thing I knew was I probably needed to do something a little more grounded. But at the same time, I didn't know what it was that I wanted. So for me, it was a very deliberative decision. I tried to read as much as I could. It was one of the most productive times in terms of trying to learn about very, very different issues, and had a lot of conversations with a lot of very interesting folks, and eventually started to come to an understanding that I could take my physics background and translate it into working on climate and ecological issues. Because there's this, I do climate modeling now, and one part of climate modeling is physics. Of course, there's mathematics, chemistry, biology, and so on. But there's a lot of space when you come from the physical sciences. So essentially, I took my sort of background in physics and I moved it from working in sort of theoretical physics to working on issues of climate.
That's great. I mean, not too many people in the world do a double PhD. Dr. Ramarao, from an economist to getting interested in environment, what prompted you to start working on environmental issues?
Start by saying thanks to Sanjay and Caspian, especially for any researcher to be recognized by stakeholders like industry or field farmers or policymakers. Will be more satisfying than publishing our work in a high-rated journal. So especially research should have relevance to the society around. With that, just now we actually started off. I've been actually, as you said, I'm a trainer. I'm trained in agricultural economics. But we have been doing research, being associated with Durand Agriculture as part of Indian Council of Agriculture Research. So our major focus is on always natural resource management, like watershed management, soil, water relations, this kind of work. But we also started some work on climate change way back in 2007 or 8 in a network project, but that was still in nascent stage. But the real impetus came to me personally, as well as to our institute in general, came in 2010 budget, actually, when the then Prime Minister, Dr. Manmohan Singh, announced some commitment of 600 crores to climate change and agriculture research in the parliament, that budget session. So that led to a project proposal on a project called National Initiative on Climate Resilient Agriculture in 2011, where we were involved in formulating the project. And it was a mega project with 40 plus research institutes in the country belonging to Indian Council of Agriculture Research, and more than 100 Krishi Vigyan Kendras in the country. So as part of this, one of the initial tasks was given to us is, as you know, that investment or financial resources are always limited compared to our needs. So we need to some kind of exercise on prioritization, what we should be doing and where we should be spending our money on, especially with relation to climate change adaptation. So that led us to the task of vulnerability assessment of agriculture to climate change, which we brought out an initial report in 2013, actually. So that actually was well received by many policy makers, including NABARD, Government of India, state level organizations, international donors like GIZ and all those stuff. So many are using that actually. Then again, IPCC brings out reports, and AR5 came in, assessment report 5 came in 2014. Then that, I think we'll contextualize in the next question that we are going to, description of vulnerability or hazard. So they came with different climate projections. Chirag knows better actually, more than me. I think so. There were different conceptualization, there were different definitions because of the evolving literature, evolving understanding of how risk management is important. So that led us to this report that you are referring to that came in end of 2019. So in a way, it's a project-driven interest and also closely connected to what we have been doing in terms of natural resource management. Thank you.
Right. So one project led to another. And of course, we will discuss about your latest report in a lot of detail in this webinar. Dr. Dasgupta, what led you to environmental research? You also come from an economics background.
Thank you. Yeah, thank you, Sanjay, and a very good afternoon to all of you. So my coming to environmental issues on environment is quite actually dramatic, and it was a decision from a reading of a night, I would say. So that time I was a graduate student doing my economics in Calcutta University, and I'm talking about 16 years back. That time we didn't have any compulsory course on environmental economics at the bachelor's level. So, but I was reading on globalization and trade. So suddenly it intrigued my interest how several commodities which are environmentally degraded, they are barred from trading. There are several restrictions and so on. So that kind of triggered my interest. So there can be a marriage between economics and environment. And then I started realizing, okay, economics is basically telling you how to optimally utilize scarce resource and what can be more scarce than environment. And then after, I would say a year or so, I came across a book. This is called The Limits to Growth by Dana Meadows and others. And I really read the book for the entire night. And next day morning, I knew what I would be doing in the future. So it was quite dramatic, I would say. So that book sort of shook my, ideas and kind of gave the shape to the later activities, whatever I did. After that, my entire specialization remained on environment, resource, and climate change.
Such an inspiring story. And Mr. Patil, you have been in this for a long, long time.
Yeah, hi Sanjay. First of all, thanks Caspian and TIE Bangalore team to organize this very interesting webinar. I think I am the guy who basically accidentally started in this sector, environment. I was having no intention to do in this. I basically a techno-commercial guy, started in agricultural risk management, managing supply chains way back in 2004. Okay, so fortunate for me, 2003-4 is the year where a lot of commodity regulations have started coming up in India. NCDs has started, MCX has started. Okay. Similarly, climate-related insurance, or you can say a weather index insurance, was started way back in India. Being an electronics graduate, I always fascinated about electronic sensors. Okay, and I was always looking for an opportunity where actually I can go back to a sensing part. Okay, so 2004, Indian government has launched index insurance, a lot on the pilot basis, and that was the year where there was no 2G, GPRS, 3G, 4G, nothing. There was only GSM or a landline telephone. And there was a big problem that how to transmit data sets from a remote location to a kind of centralized server. Okay, and actually that kind of project is very critical to create this rural agriculture insurance in India in 2004. So that my background helped me, and I thought it's a very interesting project, and I thought I will shift from my supply chain expertise into a kind of sensing expertise. Okay, so I moved into this project, and I think the observations we have started creating in way back in 2004. So once the observation starts coming, I got an interest in forecasting it. Okay, when the forecasting starts coming in, then I said, okay, how to use these data sets. Okay, then we enter into a kind of application like use satellite, ground, and create a different application. So as a person, we always see that there is a business opportunity if there is a climate change. Okay, so although there are a lot of agri-techs are basically actually formed considering climate change is an opportunity. And I can say, I think accidentally I entered, but I really love this space now.
I think that's the common thing for all of us, right? You know, really loving it and being challenged by it all the time. This is, of course, a fantastic sort of introduction. Dr. Dharab, you know, we'll get right into the webinar. And in your report, with which you co-contributed with so many authors, Assessment of Climate Change, can you help frame for our audience, which is, you know, young entrepreneurs, or maybe not so young entrepreneurs, what are we seeing? What has been the observed trends around key issues like, you know, warming, like monsoons, like cyclones and droughts? You know, these are the four things that I think most of our agriculture entrepreneurs are really concerned about. And what have you been seeing?
Thanks, Sanjay. So in fact, so what I'm going to talk about are some of the assessments that we've made in the report. And in fact, I don't think any of this is going to come as a big surprise. I'm going to quantify some of these things as we've assessed them from sort of the observed data of the last, say, 70, 80 years. I don't think any of it is going to come as a conceptual surprise to anyone here, because I think many people here, if not most, are keenly sort of informed about climate change issues. So let me try and quantify some of these quantities though. So one of the things, the most fundamental climate change indicator is of course temperature. And when it comes to India, what we've assessed is that the temperature change in India relative to pre-industrial times today is about 0.7 degrees centigrade for the Indian land region. Now, you know, to contextualize that, the global average temperature is about 1 or 1.1 degrees since pre-industrial times, but that's the global average, which means it's over land and ocean. But when you just look at global land, the temperature rise is about 1.5 degrees already. So we keep talking about these 1.5 versus 2 degrees. We are talking about the global mean. But when we look at the global land temperature, it's already at 1.5. So it would appear that the temperature rise over India is only 0.7, which is roughly half the global mean. And why is that? You know, is India getting lucky? No, in short. Firstly, tropical areas, tropical parts of the world, generally the temperature rise is a little slower than the extratropics or high latitudes. So that's there anyway. That's just a fundamental feature of the climate system. But another rather important contribution to this muted temperature rise over India is the air pollution, what we call aerosols, which is very high over the subcontinent, as we all know only too well. Among many other things, what aerosols do is they mute temperature-wise. They actually shade the planet. In a sense, they block some part of the solar radiation, some fraction of solar radiation from reaching the surface and effectively cool the surface. And so the temperature has risen because of greenhouse gases, but it's not risen as fast as it would have otherwise. Now, this is not by any means comforting, because aerosols, air pollution, they have a limited lifetime in the atmosphere. And the moment, and this is what we saw last year with all the lockdowns, the moment you stop emitting, very soon those air pollution particles, the aerosols, they start precipitating out. They start from the atmosphere, and you get a clean atmosphere. And the problem there is, there's actually a temperature rise, which it has muted. So the moment you start removing air pollution from the atmosphere, that sort of a hidden temperature rise will happen very rapidly. It's like a painkiller, really. Or not painkiller, antipyretic. It suppresses your fever, but the moment the effects wear out, which can happen quite rapidly, it shoots right back up. So that's why India's temperature change is sort of only 0.7 observed, but it's actually a lot larger than that. It's just that air pollution has muted it temporarily. Now, the other important variable is rainfall. Now, this was the important one, right? Particularly for agriculture. That's the theme today. Now, several things have happened with rainfall. One is, in the last 70 to 80 years, India's rainfall has seen a decline on average. And we've assessed it at about 6% decline today compared to the 1950s. But at the same time, the amount of very heavy precipitation events has increased. Okay, so you have a decline in sort of the average rainfall. At the same time, the extreme events have increased quite substantially. And I think from newspaper reports and so on, I think people have a sense for this in a qualitative way. But for example, to quantify it, if we look at the daily precipitation, daily rainfall maximum, okay, maximum daily rainfall. Today, it's, when I say maxima, okay, not maxima, but we define extreme precipitation in a certain way, which is more than 150 millimeters per day, which is very high rainfall. And when we look at these kind of rainfall events, they're 75% larger today relative to the 1950s. It's a very big increase. At the same time, the amount of dry spells, which is also particularly relevant to agriculture, that has also increased. So now, in the last 30 years, the frequency of these dry spells, very dry spells, is 30% larger than the previous 30 years. Okay. So both the dry spells have increased and daily precipitation, rainfall extremes have increased. And of course, given these kind of changes, unsurprisingly, droughts have increased in both frequency and the extent, areal extent of droughts. And particularly in central parts of the country, there's also this increased severity of droughts. And that also is a pretty straightforward consequence of higher temperatures, which dries out the land surface. There's just becomes drier because of this heat. And so you get these more severe drought conditions. I think the last thing you asked was about cyclones. And no surprise, one of the sort of signals that has emerged very robustly is that we used to see many cyclones in the Bay of Bengal anyway, but now in the Arabian Sea, over the last 20-25 years, we are seeing this increasing signal of cyclones, of increased severity as well. And again, there is a very straightforward reason for this. Cyclones form over warm waters. So, temperatures about 28 degrees is kind of the threshold. You need temperatures higher than that for a cyclone to really gain strength, to pick up strength. And we are seeing these temperatures increasingly in the Arabian Sea. The temperature rise in the Arabian Sea is much faster than the Bay of Bengal. And fueling these, so these cyclones in the Arabian Sea, which used to be rather few in number, they have much more energy to pick up from the ocean. And so all of these changes that we're seeing in temperature, in rainfall, in droughts, cyclones, you name it, they're all interconnected. we are seeing them in the data. There are very simple physical reasons why we expect them to happen, and our climate models can actually reproduce these trends in their simulations. So that's the.
Thank you. Some temperature rise can actually accelerate with decreasing pollution, some decline in monsoon rainfall, but more more at the extremes, more dry spells as well as more extreme rainfall, and cyclones not only in the Bay of Bengal but also in the Arabian Sea, as we saw in Bombay recently. Mr. Patil, you've been observing data for the last, I don't know how many years, you said since 2003. Are you seeing the same patterns as well? Or, could you tell us a little bit about the patterns that you are seeing?
Sure. So, Sanjay, we basically, as I mentioned, that we actively work with the crop insurance companies in India. And the moment I said crop insurance is obviously their term sheet or the kind of structure or index is based on the last 30 years data sets, which any insurance company or reinsurance company has sourced. And they basically link it with the crop weather calendar. And based on the terms actually has been prepared. Okay. So my experience based on that, because I assume that whatever last 30 years data sets which was used, and obviously this climate or we are not present or having data source of our own since that long. So I assume that is benchmark. Plus we have roughly around 3,000 stations stable network for last 1 decade. Okay. So my comparison will be based on that. So what we have observed, okay, and where actually most of the Indian farmers either they claim that we are not getting claims because my trigger has not happened. Okay, so there can be one reason. So when we cross verified that why it is happening, some people where generally historically it's a normal of say 30 degrees Celsius, and there the claims are not happening because the temperature either has surpassed or has not reached. Okay, so when we observe this trend, considering this business case, number one, in case of temperature, yes, I absolutely support Dr. Dhara's observation that yes, there is an increase on an average. There is an increase of temperature between 1 to 2 degrees Celsius on an average. In some cases, in some of my stations, we observed the variation in more than 3 degrees also. Okay. So when I say these observations, these are the sensors which basically are timely calibrated against the primary standard. So I think the comparison which we generally give is based on the sensors where we are confident on the data sets which has been captured and which has been installed as per the global norms like the WMO norms. Second, in case of temperature, wherever generally the temperatures were reaching 45 degrees, historically normals, are now very comfortably crossing 47 to 48. Okay, so the temperature, the areas where the already hot areas are sometimes most of the times are crossing 2 to 3 degrees increase. That is second. Very interestingly, I think 45 plus temperature we started observing in June and October too. Okay, all historically March, April, May is standard, but observing these 45 plus temperature in June and October is something which is strange. Okay. As Dr. Dhara also said that your dry spell has increased, the dry period basically. The same because the hot days are increased. So number of days where the temperature is on the higher side is also increased. So these are our primary observation based on say last 1 decade's data sets, roughly around 3,000 observation points on ground. Okay. Now in case of rainfall, absolutely the heavy rainfall events has increased. Okay, like you are getting almost a similar kind of rainfall, but in shorter period of days. So that means your rainy days count has been reduced and intense rain count has been increased, the number of days. Okay, we also started observing the uneven rainfall distribution. Okay, so I when I interact with the farming community, they always used to say that whenever it rains, it used to rain in multiple villages similarly way back in 15-20 years. Now every villager generally claims that in the same village, certain pockets is rained, but certain pocket it is not rained at all. Okay, so I think these are the primary feedback and observation based on my day-to-day interactions with the farmers, and also on the data sets which we collect, primarily on the temperature and rainfall.
Temperature and rainfall. So, I mean, a couple of interesting points. Dr. Dhara's comment about 0.7 degrees centigrade versus yours of 1 to 2 at least, over a 10-year period, to me, seems like an issue of acceleration of warming, which is something that I want to come back to later. But the other point that you brought up is, hot days also being in October, number of extreme hot days increasing, and very irregular spatial distribution, even in a small village area. I think these are all sort of issues of climate risks. Our webinar today is essentially to talk about how entrepreneurs, business people, should be reading climate science reports. So before we talk about the reports themselves, I wanted to just do some framing of the terms. And Dr. Dhara, you have already used the term climate change modeling when you said that's what you do. Could you tell us, as if we were all class 10 students, what is climate science modeling?
I can try. So so I think I could start with what I hope is a good analogy, which is you may know of these flight simulators, right? So if you want to test how aircraft would respond to different atmospheric conditions, or if for example, if you want to simulate how quickly you could make your aircraft actually rise, say 2 kilometers because of an imminent collision, mid-air collision. That depends on the ambient atmospheric conditions. It depends on how much fuel, which altitude you are at, how much fuel it would take, whether the engine would stall if you try to rise or drop too rapidly. But the problem, of course, is you don't want to do this in a real aircraft. But you need to experiment. You need to test what would happen under different conditions. And so what you make is a simulator. And these simulators, typically, they can model airflows. They can model what happens when the flaps of your aircraft are, their angles are changed, angle of attack is changed compared to the wind flow, the amount of fuel there is, and so on. And it can tell you whether or not your aircraft can actually safely make a certain dive if you need it to. And so we use these simulators because we cannot experiment with real aircraft. It's too risky. When it comes to the climate, we don't have the option of experimenting at all. There is only one planet. And of course, we are conducting a massive scale experiment by putting greenhouse gases and aerosols into the atmosphere, but we certainly can't conduct more such experiments. And so what do? We try and make these computer programs, and we use a computer as our laboratory. And, basically these programs are a mathematical representation of the entire climate system, or at least to the degree that we are able to represent them. So, we have our atmospheric circulation, we have oceanic circulation, we have the biosphere, there's carbon exchange. So we sort of describe these interactions, put them in mathematical terms in a computer program and run them on the computer. And of course, they are supercomputers for the most complex models. And then we can do these experiments where we shut off greenhouse gases, or we raise greenhouse gases and let the program simulate what the climate will do in the future, and what the climate will look like. And or we can reduce our aerosols really rapidly, see what happens, or what these models tell us. So that's one thing. But how do you test these models? How do we know these models are any good? For that, typically, we use the observational data. For the last 30 years, we have very good quality satellite data. If we go further back, we have reasonably good quality, ground-based measurements for many parts of the world, mostly land, ocean less so, but there is. And if you go back much, much farther, hundreds of thousands of years, millions of years, there are different techniques called paleoclimatic proxies, where we can get information about the atmospheric conditions, let's say 500,000 years ago, and so on, from ice cores that we extract from, say, the Antarctic or Greenland. And you can analyze that entire ice core, which is, by the way, kilometers thick, and you can recreate the climate history for the last 700,000-800,000 years, a million years. And then, and of course, the climate has changed. For natural reasons, the climate has changed over this time. And we see whether our climate model is able to reproduce these changes. So it's called a hindcasting. So we check against our paleoclimatic data of the last million years or whatever, and see if our models, our mathematical models, our computer programs can reproduce those changes, given those changes in orbits or changes in the orbit of the planet and so on. Once we gain confidence that we are able to reproduce that, we use the same model to project into the future. So that's climate modeling.
Fantastic. So it's a computer simulation of a complex system, and you check whether the simulation is correct by checking against historical data, over the last 10, 20 years from the data that people like Mr. Patil are collecting. But you have more sophisticated systems to check data over the last hundreds of years. There are other terms involved, right? And Dr. Rao, maybe at this point I'll bring you in to help people, our entrepreneurs, understand the other three terms which they will come across all the time when they read reports: vulnerability, exposure, and therefore risks. Hazards, vulnerability, exposure, and therefore risks. I think these are the terms everybody has to understand.
Thank you. I think these are some of the words which we are coming across very frequently in the context of climate change. At the same time, they are most loosely used terms also in the literature. So whenever in the beginning, I will suggest that whenever you read a report on any vulnerability or climate change risk, look at the definition that they have used. Because for vulnerability, there are more than 100 definitions in the literature. More than 100 definitions for vulnerability. So because we are talking about climate change, let us stick ourselves to the definitions and conceptualization given by the Intergovernmental Panel on Climate Change. So here I will always take one example of illustrating what these words mean. Suppose a guy from Chennai is going to Delhi, say in January or December, winter. So he doesn't know anything about the weather in Delhi during that part of the year. So if he goes there without any preparation, what happens? He is likely to be affected by cold or cold attacks, right? So that guy without any knowledge of weather in Delhi, without any protective wooling or with protective wear, so he is more vulnerable to the cold, harsh weather at Delhi compared to the one. Suppose other person is going from Bhopal or somewhere else in Punjab, Haryana is going. He is aware of the weather in Delhi, so he always has the protective wear that he can use there. He goes there. So investing or having the access to protective wear is a kind of adaptation. So the suffering actually that these two persons are likely to face is actually kind of risk, amount of risk that if you can put in the monetary terms or in terms of medical expenses, in terms of loss of work value, so it can be called as risk. But the person who is going there is actually exposure. So when a person is not going to Delhi, he's not exposed to cold weather. So exposure is zero there. So if he's going to Delhi without any protective gear, then he is more vulnerable. It's a kind of predisposition to some kind of damage or harm or pain. That's vulnerability in terms of the current in the climate change context. So similarly, suppose we are unprepared for a drought. Chirag was telling rice fields are more likely to come in future. So when the farmer is not prepared in terms of having access to irrigation kind of thing, then he is likely to suffer more because of longer distance or more distance. So the farmer without any access to irrigation is more vulnerable to rice fields in the future. So that is kind of how predisposed he is, person in terms of he's being equipped with to deal with the climate harshness in the future.
I love this example. I think anybody would get which is, and you have I like the way you have linked vulnerability with preparedness. And this webinar is all about, getting to know and therefore getting prepared. Dr. Dasgupta, you teach undergrad students. How do you teach these words to them?
Yeah, it's actually very interesting because these are some of the words which are very loosely, and interchangeably used in the literature. So one day you tell them one definition, next day they would definitely come up with some 5 other definitions and would ask you which one is correct. So see, one thing that I understand, if we want to streamline our understanding in terms of a particular stream of literature, then there has to be a common, common definition. Otherwise, things become very, very messy. So just following up on what Dr. Ramarao has said, how we can conceptualize exposure, vulnerability, and hazard, I just want to follow up on this by saying that, see, ultimately we all need to come up with policies that would address these components to address the risk arising out of climate change. Now, if we come to that action part, then you see that if I talk about hazard, which is more like, extreme events, changing the, climate and so on. As an individual, as a policymaker, it's not really in my hand for a short to medium term. It needs to be adjusted in a longer term. If you think about exposure, that whether you are in Delhi or not, that again is not really in the hands of policymakers for a short to medium term. You can't take the entire population out of Delhi and, posit them in some other place. That's not really possible. It requires a lot of, landscape planning and so on. But in the short to medium term, what they can address and what as an individual we can probably address in the best possible manner to reduce the risk arising out of climate change is to address the component of vulnerability. So that is where, comes the importance of vulnerability, which is a system character, right? So whenever we are talking about vulnerability in the context of climate change, we are not only talking about, the drought and the flood. We are also talking about whether the credit mechanism is working, whether the insurance schemes are there. So these are the kind of points of intervention. If you understand what are the sources of vulnerability, you also know what are the points of intervention. So that I think would be very important and discussion in today's forum.
Exactly. So the hazards are the climate events, and you can't really do much about it, at an individual company level, because that's what we are talking about. But there are things we can do about vulnerability, and that's what we'll talk about. So, and that's exactly what we're going to talk about right from the next question, which is, I want you to think in the next 15 minutes, put yourself in the shoes of an entrepreneur who is working in Maharashtra, and his or her business is to sell fresh fruits. You can think about your favorite fruit, strawberries or whatever, vegetables and milk, which he or she, her team procures from various districts in Maharashtra. It's a large state, and sells them to Pune, to Mumbai, Nasik, urban customers, using a very sophisticated web app. Now, Dr. Rao, you have written your report on risk assessment of Indian agriculture, and it's a if anybody hasn't read the report, I would really recommend you to look at it, because it's a district by district assessment of the risk. Now, how should this entrepreneur in Maharashtra be reading your report and getting prepared, as you say? Dr. Rao.
Very interesting question. I think, first of all, before going to the report, actually, what I naturally do is that what it does take to start an enterprise on promoting fruits and vegetables or dairy, whatever. So what is resources that are required for going for taking the industry like fruits and vegetables? First of all, natural resources in the district like soil, water, irrigation, rainfall. So this is the one kind of requirements. And here again, you don't have much control on in terms of natural resources. On the other hand, demand side condition like what are the income levels of people there, what is the labor productivity, their districts. So what is the population density? So all this kind of information is available in this analysis, because we conceptualized climate change risk as already brought up in the discussion as a product of 3 different dimensions: exposure, vulnerability, and hazard. So for out of these 3 dimensions, again, we represented each dimension in terms of different indicators. So for example, in vulnerability indicators, we took about dozen indicators, where we talk about what is the soil groundwater availability in each district, what is the soil condition in terms of available water holding capacity of the soil in the district, what is the rural population density in the district, what is the per capita income in the district, because demand is actually a function of incomes of people in the district. So if you want to locate your industry where in certain locations, these are the conditions that we can easily identify. So this is the beginning. This kind of information will be available in this work. But at the same time, it's not enough, because the district is still, because we did the district level analysis, because district is the administrative unit in the country for most of development planning and administration. But still, there is variability within the district also. That is not available in this. We have to go for some other sources, especially state government resources are available, where the block level or sub-district level data is already available. But if you want to bring again the context of climate change into that, we actually made available the climate projections. Because this is about agriculture, we always try to think in terms of the indicators which are relevant to agriculture. Agriculture, monsoon is very important. So when we say monsoon, the months of June and July are very key. So what's going to happen for June and July rainfall? What do the climate projections say about June and July rainfall? So whether how the rainfall is going to change in future. So that is critical for sowing operations or crop planning. Similarly, how the dry spells or drought is going to increase, decrease, or change over time into the future. So how the climate part, this brings actually question where you can, especially we talk about protected cultivation, soil water conservation, rainwater harvesting, all this kind of interventions you want to make, this kind of information will be useful, including the extreme rainfall events. So we conceptualize 4 kinds of extreme rainfall events in this analysis. So how the rainfall is extreme rainfall is going to increase. There are different definitions of extreme rainfall again, but for the sake of uniformity, we took like a maximum rainfall event. So how much it is going to change in the future. Similarly, 99 percentile rainfall, how it's going to change. So because these have implications to rainwater management, groundwater management, power bills. So all those kind of things have implications. And one more thing is that protected cultivation, this kind of thing, not protected cultivation, rainwater harvesting, because most of the climate projections say that annual rainfall, annual scale is going to increase in the future, at least by 2050 century period. So we have more opportunities for harvesting rainwater. So where we can harvest extreme, even the extreme rainfall events are also an opportunity to harvest rainwater. So we have to have plans for rainwater harvesting, because there is more possibility to harvest more water going forward. But at the same time, we have to use that water. We have to make provisions. We have to have technologies to store that water and to use when it is actually needed. So say dry spells. So we have more water to be harvested, but again, we are likely to have more dry spells, longer dry spells. So this, how to protect and conserve this rainwater harvested till the periods of dry spells. Otherwise, if we cannot store this rainwater to the period of dry spell, again, it's not useful in terms of agriculture. It has other purposes, but as far as your crop planning is concerned, that may not be more useful. So we have to we can harvest more water. We can use that water to save the crop during the dry spell. So in that fashion, actually, district-wise information is available. But I would like to say that again, there is intra-district variability is still there. Some districts are very large, so those things have to be factored in.
Right. So I'll just summarize it for our audience once. So this entrepreneur, he or she can look at all the districts of Maharashtra, and you have in your report, you have got models of not only annual rainfall, but rainfall in June, July, prediction of drought, likelihood of drought, of course, prediction of likelihood of extreme rainfall events across all these districts for at least one reasonable time period. and then you have indications of vulnerability. So based on that data, this entrepreneur can decide, which districts are more vulnerable, what is the type of hazard that he or she is likely to be exposed to, and therefore, take corrective actions. And you have already, of course, started talking about one corrective action, which is rainwater harvesting. But, I'll come back to you for more corrective actions later. And then Dr. Dasgupta, you have done a similar sort of analysis, but yours is, as you have already alluded to, much more focused around vulnerability. Let's talk about the same entrepreneur. And he or she has read Dr. Rao's report, and now, it's a Friday afternoon, and he or she is reading your report. What is it that she should be looking at in your report?
Friday afternoon is a bad time to read our report.
Okay, no, it's a Tuesday afternoon.
Yes. Yeah. So jokes apart, so it's kind of it follows from what Dr. Rao has said. So if you look at our report, we have focused more on vulnerability, which means we have not taken into consideration, and very carefully we haven't taken into consideration any weather related or climate related variable. The reason, let me explain, because this is one of the questions that we often face, that if you can understand what is the vulnerability at the current climate scenario, then that is going to be augmented if the climate changes. So if you calculate the current vulnerability, then you know what is the best possible situation that you are in and which is going to be worse in the future. So if you look at our report, this is not only the agricultural vulnerability, but this is a more comprehensive vulnerability, socioeconomic vulnerability in terms of infrastructure that we are talking about. So if you really want to, understand, for example, how you run the business, for example, in a certain district of Maharashtra, then I would say you start from the back of the report where all the data are given. So this is one good thing about the report, that we have given, the data for, as it is also given in the CRIDA report, the data for all the districts, all the indicators that has been used, the source and data for all the districts. Now, how do you read the data in order to aid the purpose of yours? So I would, talk about the following approach. If you want to run a business, you need to understand the demand side as well as the supply side. Now, let me try to identify certain indicators which are sort of demand side indicators and certain indicators which would be the supply side indicators, and how they are related to the whole discourse of climate change and vulnerability, so on. So, for example, suppose I run a dairy business. So there is an indicator which is called the livestock to human ratio. So if you find out that there are districts where the livestock to human ratio is very less, then you know that this district has a potential where the livestock rearing can be much more. That not only creates a livelihood opportunity, but it also sort of gives the population in that region a cushion when certain climate extreme events happen, because these livestock act as sort of an asset which can sustain some of the climatic events, and those can be sold off under huge distress and so on. So this is one indicator that you can look at. So this is, again, you are choosing where to operate and how that can aid to the larger discourse of development. Next, you can also look at the indicator which is called the yield variability. So see, this is not this apparently this has nothing to do with the climate or weather data, but yield variability means if you take a particular crop, then how the yield or production per hectare of this crop is varying over a period of time. If the variability is very high, that means the production of this crop is highly sensitive to the climate events. So if you can identify the areas where the crop variability is high, then probably you can motivate the farmers in that area to switch the crop from the one which is highly variable, whose productivity is highly variable in nature, to some other crops, for example, horticulture or vegetables and fruit trees like that, which are more resilient to climate change. So if you go through these indicators, they will kind of give you an understanding what would be the location from where you can collect the material which can go to the market. Next, coming to the demand. Now, again, as Professor Rao has said, one of the major indicators of demand is the income that you have. So you look at the districts where the per capita income is high. you look at the districts where, women participation is labor force is higher, because these are the areas where you can, sell, milk or nutritious food more through a kind of, penetrating it in the family. So look at these kind of districts. Look at the road connectivity. So that's one of the major challenges that you see in the context of, climate change adaptation. Look at the road connectivity. Look, where there are more infrastructural is there. Look at the districts where IMR is very high, that infant mortality rate is very high, which shows that the health condition is not good. So you try to identify these places as a market of nutritious food that you are planning to sell. So this is how I would suggest that first thing that you can do, go through the numbers that are given to the end of the report. And then you come to the state specific report where a district level analysis has carried out by the state itself. So the understanding that has gone into that part of report is really deep. So this is how I think you can, make use of the report.
Fantastic. So start with the data, and I really like this, start from the back of the report, and identify, what the data means for you in terms of supply and demand, and what it means, linking with what you and Dr. Rao said, what it means in terms of preparation. That even if there is an extreme climate event of which we have no control of, which you have already referred to, what is it? How can I be better prepared, both in terms of demand and supply? That is what you'd, that's what our entrepreneur can get out of your report. However, getting to understand the data is one thing, but taking action is completely another. So, Dr. Rao, I'll go back to you, and you have already mentioned one action, which is, rainwater harvesting. But district by district, can you help this entrepreneur sort of define that range of actions he or she can take based on the data that is available in your report?
The report provides what kind of risk or what kind of hazards that the district is going to face to different degrees. But there are a range of technological options, management options from the farmer's point of view. So that brings again the other enabling. I see private industry as an enabler of technology adoption or better livelihoods and other kind of things. So one thing is that ICR, Indian Council of Agriculture Research, as well as State Agricultural University and private researchers, private industry is also a very significant player in agriculture research and development. So they are coming out with a lot of improved crop varieties, including fruits and vegetables, which actually is resistant to the dry spells or heat stress or temperature stress, or which are short duration to come to their maturity, so that they will escape the harsh weather kind of things. So there are crop varieties available for that. So we can actually participate in trying to locate that kind of varieties and making available the kind of seed material to the farmers. This is the first one thing. And second thing is already talked about rainwater harvesting. And actually CREDA has in somewhere else in other reports, for Maharashtra especially, they did some analysis on opportunities for rainwater harvesting, how they're going to change over time. So how the rainfall is going to change in future. So what is the runoff potential that can be harvested, so which can be made available to the agricultural crops as and when they needed. So that specific analysis is already available in CREDA's research work. Also micro irrigation. So if you look at the country, so there is potential for about 40 million hectares for micro irrigation. But right now it is actually less than 10 million hectares because efficient use of rainwater. Climate change actually boils down to efficient use of anything and everything. So you have to use your resources very efficiently. That actually helps you in both kind of in adaptation as well as mitigation. So use actually there is one concept called climate smart agriculture in international literature being promoted by Food and Agriculture Organization, the United Nations organization. So that's actually that sees climate smart agriculture as a combination of nutrient smart, water smart, energy smart, policy smart kind of agriculture. So when you say nutrient smart, you have to reduce your fertilizer use in crop production. We are talking about organic cultivation and all things. But one of the key pollutants is the use of nitrogen fertilizer used in crop production, be in crops like rice and wheat or other crops. So we have to reduce the use of nitrogenous fertilizer in particular, and all fertilizer use in general. So there is scope for technologies and improved inputs into recently we are talking about nano fertilizer kind of thing, neem coated urea. So these are the kind of initiatives that we can look at. Also, balanced use of fertilizer is another area where we can actually we can protect the crops. Balanced use, right now we are giving emphasis on use of nitrogen compared to phosphorus or potassium and micronutrients. So balanced use of, just like human beings, we talk about an ideal mix of dietary diversity and nutrition diversity. Similarly, plants also need actually both NPK, nitrogen, phosphorus, potassium, they are called actually macronutrients, and other iron, zinc, sulfur, these are called micronutrients. So there is should be adequate emphasis on both macronutrients and micronutrients, and as well as the ratios of applying to the croplands. So this is another area. Actually, there are KVKs and agricultural universities and Indian Council of Agriculture Research. They are technologies, they are methods, and they have proven what to be done to protect the crop in this kind of situation. Another thing is plastic culture, plastic mulching, especially in vegetables like tomato, brinjal. Actually, use of plastic, spreading the plastic on the surface actually reduces your loss of moisture from the soil, loss of water. So if you use plastic culture, plastic mulching kind of things, actually, micro irrigation, another kind of technologies. There are a number of technologies available which can be used actually to deal with the aberrations or hazards that are likely to exist in the context of climate change. In terms of dairy, again, fodder shortage, especially during summer, is going to be one of the manifestations of problems of climate change, especially in the situations of drought. So we, especially in Maharashtra, we hear about farmers selling their livestock or farmers taking their livestock to animal camps in a distant place. They took their animals to a place where fodder is available for a month or two in summer, then bring back the animals to their own village. So we have some certain interventions where we can make silage out of the green fodder or clay fodder. Then we can store that silage during the periods of lean period shortage, like especially during summer months. So this kind of technologies are available, and the one thing is that we also talk about institutional interventions when we're dealing with climate change. Our report also has some information on self-help groups. They actually relate to women, and women are more linked to livestock compared to men. So that information will also be useful in planning livestock enterprise, and also insurance. I think Yogesh will be a better person to talk about insurance, but insurance has a potential, is useful, is needed, and everything is, we know many of the problems, but there are 2 or 3 caveats for insurance I would like to flag here. One is all said and done, still the basis risk in insurance is in agriculture. Still, agriculture risk is more covariate compared than it is idiosyncratic risk. So agriculture risk is still more covariate. So, and then again, the quantification of relationship between weather and agricultural yields or incomes is still not adequately done. So that is also another reason why basis risk is high. And there is another thing is that already agriculture insurance, and you can look at the premiums and payout ratios for the country level, they are not still favorable. But when we say that climate change is going to be unfavorable, or it is going to lead more yield variability or income variability, obviously the premiums have to increase. Unless
right. So, I mean, a range of options, climate smart options, which includes resource efficiency, but then you ended with, risk mitigation as well, which is insurance. So, a full range of options which are available almost as a bouquet. Dr. Dasgupta, any additional sort of measures that this entrepreneur can take based on the reading of your book, your report?
Yeah.
Especially, and let me just phrase this a little bit, especially because your report on vulnerability is not just agriculture, right? So it is more sort of broader, right? So in that context, how can it use your data for adaptation planning in the districts that it is operating?
Yeah, so I'll just, I'll talk about those which are not mentioned by Professor Rao, because some of them are really overlapping and you always get these indicators which can be worked upon. So one issue I would like to mention is the informed decision making. So as an entrepreneur, when I'm procuring the product from the farmer, it's very important that the farmer is making a decision which is informed. Now, this is probably a kind of business model that the AgriTech companies can think of, how to provide correct information to the farmers. Because I give you a small example, we have not as a part of this report, but separately we have experience where in the Kashmir Valley, the farmers are shifting from paddy to apple cultivation, but they don't know what the problems are associated with the apple cultivation as well. So the next option that they are going to, that probably is not the best possible option that they should go to. So this is one point of intervention which would be very important, and that needs to come from this kind of companies to the farmers. And I have been actually seeing a number of questions about the marginal farmers. And if you think about the marginal farmers, this kind of providing of the information is very, very crucial to them, because they really don't have access to information. They don't have access to technology. They don't have access to resources. Therefore, the decisions that they take, in terms of, what is the time of sowing, what would be the time of harvesting, what to produce, these kind of decisions, many a times it may go wrong. So this is one very important point of intervention where these companies can actually make a lot of contribution, and that can aid to climate change adaptation. That is one part of it. Credit and insurance. I mean, there is no, that has to be there. And that is not really working very well in India, I'm sorry to say, because in many of the districts, we have seen that very small fraction of land is actually covered by the centrally funded or state funded schemes like that. So that's another, way of intervention. The third point, actually 4 things I wanted to mention. The third point is, we know that there is a lot of livelihood pressure on agriculture. More than 60% people in India, they are actually based depending on the agriculture. And as the hazard increases, as the climate variability increases, we can't really deny that the productivity is going to fall probably. We can't accommodate more and more people in the production sector of agriculture. So in order to support the agriculture, there has to be the AgriTech industry, there has to be, food technology, there has to be allied industries which has to come up. And one potential source towards adaptation is to see the farmers who are not being able to cope with production activity, how they can be absorbed in the allied industry that can come up with the agricultural sector. And one more very important thing which is going to play an important role is the packaging. As the temperature increases, how do you do the packaging so that the shelf life increases, so that it lasts long when you are transporting it from one place to other. So these 3 are very important. And the 4th one, that's more generic. See, this is the role of, women participation in the labor force. There are, multiple ways through which women participation can actually augment the development of the area. So this is another way these companies can make an intervention to, by accommodating or by giving the opportunity to more and more women in the locality to develop the corporations, to develop the self-help groups and so on. So what I'm saying is that you can actually get good entrepreneurs from women, which has been overlooked for various years. So that is another way to explore things. So these are the 4 things I wanted to talk about, in addition to what Professor Rao has already mentioned.
And because these are broad, so
yes,
that you brought these up. Vishek, I'll come back to you later, just flagging this off for you immediately on 2 points that Dr. Dasgupta said, which is about credit and given your experience around microfinance and financial inclusion. I'll also come to you for your comments around women entrepreneurs and women. I'm going to add a point there. Credit to women farmers as well. But hold your thoughts. We have talked a lot about this entrepreneur who is selling fresh fruits and vegetables in parts of Maharashtra. I want to just step back and say many of the people who are on this call today are in their 20s and 30s. Almost everybody from the Caspian group is in that age. I definitely am not a representation. Dr. Dhara, you have done in your climate modeling, what do you expect them to see by the time they come to their 50s? That is by mid-century, which I know is a sort of important year in climate science.
Sanjay. So I think I'll try and make this quick because I just realized that there might be questions and we are getting close to 90 minutes. So very briefly, one thing we've assessed for temperature rise, for average temperature rise over India is in excess of 2 degrees by mid-century. But of course, here, there are different kinds of climate change scenarios. They are sort of defined by the IPCC. And I'm speaking of a particular climate change scenario, which is called the RCP 4.5, which is kind of a mid-range emission scenario. And we I'm deliberately talking about that because I don't want to use an extreme emission scenario, nor do I want to use a very optimistic one. But this is what I and several of my colleagues, we consider more realistic. That's arguable, but that's how I'm talking about it today. So in excess of about 2 degrees by mid-century temperature rise, and remember the current one is about 0.7 is what we've assessed. So that's quite a significant change in 20 or 30 years. Heat waves, that's the big one. We've assessed a change in the frequency of heat waves by about a factor of 2.5, a factor of 2.5 greater than the recent past. And the average duration of heat waves by about 20% more than the recent past. By recent past, I mean the last 30 years, on average of last 30 years. Precipitation, I think Dr. Ramarao already said it. We generally expect precipitation to increase, and we assess in the range of about 6 to 7% in the next 30 years. And certainly an increase in a rather big increase in extreme rainfall events. I'm not going to quantify that because there's a very wide range among climate models on this score for various reasons. We can't model them very well just yet. But what is certainly clear is that there is going to be an increase with global warming. And in fact, the rate at which this increases is generally faster than the rate of change in the mean rainfall. And finally, cyclones. Once again, cyclones are also a complicated business, but cyclogenesis, as we call it, the formation of cyclones and the frequency is relatively difficult to model into the future. But one thing that's very clear from the theory and from the models is that intensities are going to continue to rise, and particularly in the Arabian Sea. Because as I said, the Arabian Sea has been warming faster, more rapidly than other parts of the northern Indian Ocean. And that's also projected to continue into the future, which is directly connected to fueling cyclones of greater intensity.
Right. I'm glad that you sort of contextualize this in the context of moderate emission scenario, because that's what we should expect, assuming all the countries, get to their, at least all the major countries get to their net zero standards. And I think there's increasingly political pressure to do so. One thing, we're coming to the end of the orchestrated amount before we take questions. But Mr. Patel, I wanted to come back to you and ask you one question. Dr. Ramarao talked about a range of technology options at the farm level. In your experience, having worked, practically, how hard or difficult it is to help farmers move to these technologies?
Okay. So, Sanjay, I think we have seen multiple agricultural technology companies in the agricultural area. particularly in trying to influence and are influencing the farming community. But their primary aim, whatever I've seen, is not to influence the farmer. Okay, so basically they are trying to create a value in the agricultural value chain and other stakeholders also. That is their primary aim. Okay, I have not seen any agtech startup who completely focusing on making farmers climate smart. I think that is the primary task of the policy intervention or the government or the research organization. Okay, so that is one. Absolutely, agtech companies are can influence and create things for farmer, or you can influence them to use the technology. Okay, I can give some examples like companies like us. Like we generally have a top-down approach. So we use SAT, IoT, and all other activity, and we generally provide alerts or kind of climate smart solutions to farmer on the larger area. Okay, it's not very plot specific as on date, but the larger area. Okay, there are certain startups who basically provide solutions to farm specific. Okay, so they go for a precision ag, put the sensors in individual farm, create a pest and disease model, and provide an advisory to farmers. Okay, so when we talk tech, okay, I'm generally talking about the farmers which are on the topmost pyramid. Okay, I'm not talking about small and marginal farmers. Okay, they are the most difficult people to reach out generally. Okay, because generally my experience is that generally doesn't carry smartphone and all. It's very difficult to reach out even if for the institutional credit and everything. I'm saying not for insurance also. Okay, but if you talk about this, I think it is very essential to make them aware about the climate change or climate risk. We need to engage them, and ultimately, I think their action is also critical. I think to make the entire society as in climate smart. This is what generally I think it's a CRIDA term, that climate smart village or climate smart agriculture. So their involvement is very critical. I just want to give one example of making them involved, particularly the children. There's a one district in Maharashtra called Latur, and very interesting project I experienced a couple of years back. There is one local farmer leader or the activist has basically started a community radio for climate change and its risk communication to farmers particularly. Okay, so he started that by saying, okay, this is a radio where a gram panchayat can have, and weekly or daily he can bring a different experts from climate change and he can communicate and make them aware. Okay, so once he started, he understood that the making them aware in the schools or colleges is more critical. Okay, so they started putting these radios in every school and colleges of that districts or around his tehsil. Okay, I think that is something has started becoming more influential in making them adopting the new technologies. Okay, but ultimately is absolutely government without the policy intervention is absolutely not possible. Only agtech companies can't do this. They need a policy support and ultimately in capital also, both. We need, I think, we need something like EV, whatever government policy and government intervention in this electric vehicle policy. I think we should see something in the agtech space also. Unless and until that kind of intervention happens, okay, it is very difficult. Okay, and the last requirement is absolutely a capital one. Okay, we need more and more Amazon kind of climate fund, more focused on the agriculture side. Okay, because I think most of these agtechs are either bootstrapped or very barely funded. Okay, and I think once you have this, I think the agtech will start delivering in convincing farmers to adopt these technologies.
Right. So I think communication is an important issue, and I do hope some people on the foundation and CSR sides have heard what you said here, Yogesh. Even we should make that message very clear that they need to be able to provide certain type of risk absorption funds to make this communication very, very open to especially small and medium farmers who are difficult to reach, as you immediately said. Abhishek, maybe you want to just sum up this part of the discussion by reflecting on two or three issues. One is, how should AgriTech companies, you've seen the type of data that is available, how should AgriTech companies sort of implement climate risk in their own business, and reflect on those two questions that Dr. Dasgupta brought about, which is, financial inclusion in farmers, especially women farmers and women entrepreneur farmers.
Yeah, thanks, Sanjay. And of course, there are a lot of things swirling in my head. So I'll try to kind of condense it and summarize it. So of course, the problem is quite challenging. And is it one actor that can solve all these problems? I guess the answer is no. And multiple actors are required. From our limited experience, historically, we've essentially we've had the privilege of shaping the financial inclusion industry in India as Caspian. And one of the things that I think we were able to do well was kind of blend social sciences along with the money to really kind of create for-profit business models that were scalable to kind of bring in a little bit of a change. I won't say that we've changed everything, but at least the condition is so much more better. Now, drawing from that experience, from that financial inclusion experience, what I can clearly see is that the entire set of issues around climate change and financing is even more complex. It's not just about social sciences. Now you have climate sciences also that needs to be added to the mix, along with getting the right kind of financing. So we were successful in getting the right kind of funding or financing for the social issues or the social milieu that we were kind of dealing with as far as financial inclusion is concerned. What we want to do going forward is obviously add this angle of climate sciences to it, and bring in the money, which actually kind of does justice to the concerns that social scientists or climate scientists would typically raise. So that's what we, I think at the beginning of the session, I was talking about us launching a platform to be able to do that, both in terms of sharing knowledge and also about bringing in innovative financing mechanisms. But without even having done all of that in a platform kind of a basis, what we've done till now, in some sense, for example, is we've had the privilege of working with, for example, Yogesh's company, SkyMet, where we kind of helped in financing several of their automatic weather stations, which were essentially providing data to insurance companies to provide risk mitigation services or crop insurance to the small farmers, crop insurance to small farmers. To Dr. Dasgupta's point about increasing awareness, we funded companies that actually go about sharing information with farmers, especially around climate issues and market factors in poorer states in the country. We funded the largest organic food products brand in the country, and we basically funded a number of agri-tech companies which are operating in improving the efficiencies of the agri supply chain by, for example, reducing wastage. Trying to get better or more remunerative prices for the farmers, and not just that, but also, for example, trying to transition their supply chain into a more low emission kind of a supply chain. Now, that's not been perfectly easy. It has been difficult because of two reasons. One, like Yogesh mentioned, lack of capital. And the other aspect also is that a lot of the research that has happened is still not fully understood by the non-scientific community, of which includes the entrepreneurs as well. So I think there's a role for people like us to play, where we can, through these kind of sessions or discussions, we can bring this knowledge that is already there and enable agri-tech companies to transition into a more sustainable supply chain business, so that they can't just they don't just improve the supply chain quality, but they also improve the income at the level of the small and marginal farmer, which we all know today is possibly the most riskiest livelihood that you can be in, and possibly the least earnings that a farmer or small farmer typically gets. And that needs to change. And I'm hoping that with the combination of the knowledge and the financing, we would be able to kind of fast track the process of having a more sustainable and an equitable agri supply chain per se. I think that's what I had to say, Sanjoy, to this.
Right. This is great. And I think, one of the questions we had is about how to improve the productivity the productivity of the income of smallholder farmers, by one of the entrepreneurs in this in the chat box, actually by our client, actually, Hema. And maybe Dr. Rao, this has already come up. Dr. Rao, any final thoughts on that question? How does an entrepreneur improve the incomes of smallholder farmers?
I think there are 3 or 4 options that we can consider for increasing incomes of farmers. One is technology, maybe improved varieties, better fertilizer management, better nutrient management, irrigation, kind of things. And second thing is diversification towards high value crops. As you said, diversification towards fruits and vegetables. But that calls for action in other spheres like value chains, supply chains, market linkages through farmer producer organizations. So just by saying that you grow tomato or potato is not enough. So you have to link those farmers to markets. So you have to invest in supply chains and value chains. And then the third one is incentives by the government in terms of procurement price or procurement and minimum support price. They should be effective right now. Though they announce MSP for 23 crops, they are effective only in rice and wheat. The crop, especially millets, pulses, and oil seeds, they are not effective. Only hardly less than 5% of this production is actually procured by the government agencies. So there is market price fluctuations. And then fourth one is cost cutting or cost saving. You have to reduce the cost of production. So there are other avenues decreasing cost of cultivation or cost of production thereby. So cost saved is actually income management. So there are 4 or 5 avenues, and there are options for each of these things where technologies are available, options are available, success stories are available, different places, but they are lying as islands of success. But we need to mainstream them, we need to promote them. As I said, it needs a combined or orchestrated action among different actors, research agencies, private agencies, investors, NGOs, CSR initiatives, government, including government agencies. So that needs actually concerted effort. And diversified, we have to take people out of agriculture also. Right now, our 14% of GDP or GVA is coming from agriculture, but 51% of people are dependent on agriculture. Essentially, you are sharing more than half of the population, or workforce is sharing 14% of GDP. So that talks about the inequity of agriculture or low productivity of agriculture. So we have to take people out of agriculture. For that, again, we have to invest in skill building of the people. Skilling India mission is already there, the government of India. So we have to act on different fronts so that the farm's income can be increased.
Right. So range of crops and a range of technologies, but also working with other programs is the message for our aspiring agricultural entrepreneur. The one question that has come up, and we had kind of the last 1 or 2 minutes, but I think this is an important question and we should take it, is that this research, these models will change, right? We will update the models, and various agencies will be doing it. What's the best way, according to you, to sort of have a centralized place where entrepreneurs and farmers can go to get these models? And reflections from all of you on this topic. Maybe starting with Dr. Dhara, you.
I think I'm not the right person to really answer this question. So I think the others are probably better placed to take this question than I am.
So the question is, what is this? What's the best way to make this data centrally available? The vulnerability analysis and the climate projections that you make, and so on and so forth. I mean, theoretically, if you have a web portal, right, which is continuously updated.
Right. The data itself. Yeah. So it's something which we have found some difficulty with. There are several departments that are not very keen on sharing their data. I'm really not going to name any names here, but I think many of us have probably bumped up against those problems. So I think especially those institutions that are publicly funded, they really should be forced to share their data on a central portal. I think this is, I'm not, I don't know how one might go about doing that, but certainly there's a lot of data, important data out there that sometimes has to be bought. And it's extremely expensive if you're not within that sector that gets it, within the sort of that group of institutions that gets the data for free. So I think these are, particularly given the risk assessments that we need to do. Our report is, fortunately, all the data that we've used, they are all available. Climate data is available on the CMIP. They're called CMIP 6, CMIP 5, and CMIP 6. All this data is available for free. There is no problem there. Anyone can go and pick up that data. You just need a little bit of technical know-how, not too much, to be able to grab the data and then sort of start working with it. But observational data, which is critical for some of this work, that's something which has become something of a problem. Although there have been some developments. So, for example, ocean data, I believe, that's become more readily available now. But when it comes to ground measurements and so on, those data need to be available for free for the whole public, at least for non-commercial use.
Right, but just zeroing it a little bit onto a district level data. Dr. Dasgupta, your type of data, and Dr. Rao, your type of data. Is it possible to think of this available on a web portal, which an entrepreneur can sort of look at? Updates to your reports coming in the same web portal. Is it possible at all?
If you want me to be very honest, the answer is actually no. Why? I'll explain you why. Because see, the data that we have used, these are all publicly available data for one part of the report. The other part of the report that the states have developed, those also came from the public sources, but they had to put a lot of effort to get this data from the block level to from the district level. So at the very first place, the challenge is that we don't have data. Forget about putting it in one place, we don't have data. If you ask me the socioeconomic indicators, you actually get those in every 10 years. So to be very honest, the data that I'm using in today's vulnerability map, that's actually the data from 2011. I don't know what is the how well that is actually reflecting the current situation. So that's a very, very challenging problem that we have, that we don't have the data. That is problem number one. So if the organizations, the institutes who are working with the data, they don't have access from one single portal, then it would be very difficult from the companies who actually, think about a central location from where they would get all information. But I would say there is a way out. It's more like, a hyperlinked search. So once you find out one report, you can always get into touch with that particular institute or organization. And we are always, very happy to help you out, to connect you to the other institutes, other resource material, which you can actually look for. The other problem that arises, I would tell you, and that's again a very practical problem, when we carry out this kind of exercises, they are usually funded by external agencies. So for example, the report that we are talking about, that's DST funded. So tomorrow I can do another similar project, which will be funded by MOEFCC. So these two documents, in spite of being very close to each other, will be hosted in two different portals of two different ministries. So to be very honest, it would be challenging to have a central place where you have all relevant information. But yes, if we can, get hold of one institute, then you can always, get into touch with multiple of them.
So some effort has to be put together to thread the data, is what you're saying. Dr. Rao, any reflections on this topic? This is a question that has come up several times.
I agree with what Dr. Dasgupta has told. Actually, there are actually now we are investing in data generation, right? So people are asking for to generate returns from investment data. So yeah, as a government agencies also, we are also forced to generate resources for our own research funding. So there are, I think we need to develop protocols, what kind of data, what detail can be shared. So we cannot share all the raw data, but in what form, what kind of communication products prepared out of the data can be shared. We need to protocol. And then second thing is that not all data is actually usable by all the stakeholders. If you talk about remote sensing products, actually, that needs quite a bit of skill and understanding to how to use the data. If the data is based and it is wrongly used, actually it is maybe actually problematic also. And as far as our work is concerned, actually I will share the link. We converted all this report into a mobile app. So that link I will share with you. You can share with
that'll be wonderful. That is exactly the type of stuff.
I will share. And also this report is available. You can just Google NICRA, N-I-C-R-A. So that will lead to the project website of which this project report is a part of. So our technologies options, whatever we are going to do, we are doing for the last 10 years, it is available in that website. Just Google to NICRA, N-I-C-R-A. So that will lead to NICRA website. So there some data on climate technologies. We are working in 100+ KVKs in the country. So all those reports are available.
Right. This is fantastic, and I think we should take you up on this. One final question. I know we are 7 minutes late, but maybe one final question, because that's so. Is that we have already talked about data is available at district level, but for things like high level, some resolution data at the block level or village level, are there any technologies like drone technologies or satellite technologies which any of you are working on?
Sanjay, I just want to add something onto this because data, particularly related to agriculture, is always a kind of topic for debate since last few years in the AgTech community. I think with a lot of pressure, the government has started working on building national agri-stack. Okay, so what they are trying to do is basically they're creating an individual farmer identity, okay, based on the satellite GIS, okay, and they're also trying to bring in private partners for that. I think they have already signed a few of the memorandum of understanding with large IT companies and also on the large agriculture players, where they're trying to create the use cases based on the data sets which is collated. Okay, like for example, Pradhan Mantri, your PM FBO, Pradhan Mantri Fasal Bima Yojana, is a great source of data aggregation. There you are receiving farmers enrollment, farmer data set, land record, climate data sets in terms of observation. Okay, and all that data is basically coming onto a kind of one single portal. Okay, now I think there are already some pilots have started coming up. Okay, so that the AgriTech or other researchers can start using that data to create certain basically products or kind of applications around it, which can directly be applicable to farming community. Okay. And I think from our side, being a contributor from the private side, we have actually launched a platform called SkyGeo. So in that platform, whatever data sets we have created in last 10 years, you can say a decade, in terms of satellite observation, crop signatures, certain raw data sets, okay. Also on the historical forecast, what we have made, our reports and all, we actually made it public. Okay, so people can come onto that platform, can request. They just have to tell what kind of data sets they require, and we basically provide them. Okay, basically the idea is that the machine learning we understand, but to do a machine learning, you need a lot of data sets from where the new people will get it. Na? So we are trying to support whatever we can do, but from our side, we are actually trying to create a partnership with the governments where they can have a centralized database.
Oh, this is fantastic. Again, I think we should take you up on that and, help propagate your website. Any final thoughts on sub-district?
One second. There is another report which is on the district level analysis. So this report is called Prioritization of Rainfed Areas based on a multi-dimensional composite index. That report is available at the website of National Rainfed Area Authority. So that has a lot of district level data.
The National Rainfed Authority.
Area Authority, NRAA.
Yeah, I think that is also something that we would share with our audience. Any final thoughts on lower than district, block level, using satellites, using drones, using new technologies? Anybody working in this area in India?
Actually, there is an organization called NBSS, National Bureau of Soil Science and Land Use Planning. They are working on soil suitability for different crops. They are using remote sensing data and working out which part of the country is suitable to grow which crops. But still, that's not in the public domain, but based on the need, they can share that. Okay. They are actually doing it at block level, sub-district level analysis.
Okay, so we did have a couple of questions on that, and I hope we have answered that. So more or less, I know we have overspelled time, but I've been tracking the questions, and I hope I've been able to summarize some of these questions together in this webinar. To end this, I guess I should thank. First of all, I should thank all our panelists. It's not easy to take your time off and come here, but I really, it was wonderful for me to host you, and I hope